Okay, we're going to use logs to solve exponential equations. So we know this is an exponential equation because the variable is in the exponent. So anytime you're trying to solve an equation when the variable is in the exponent, you can use logs and properties of logs to solve them. So the first thing we want to do here is we want to apply a log onto both sides of this equation. Remember the golden rule of algebra: as you do to one side, you do to the other. And so we can apply the log on both sides. The second thing we want to do here is we want to use the property, the product property here, when we have an exponent on the argument, that exponent can move down front. And that's how we get the exponent out of the exponent, if you will. So we're in base 10, remember, since we do not see the base, we're in base 10. And this is multiplication, so then we're just going to undo multiplication with division. So we're going to divide both sides by log of 3. Anything divided by itself is 1. 1 times x is x. And then at this point, we're going to go ahead and plug it into our calculator. So recall the log is going to be control, and it's right next to the 1, the log button. And so we're going to have the log of 14. We're going to have to put the base in, which is 10. 14 divided by base 10 again, and of 3. And here's our answer, 2.402. We're going to go ahead and go 3 decimal places. So approximately 2.402. Now I want to remind you that a logarithm is an exponent. Keep that in mind. Always keep that in mind. A logarithm is an exponent. Okay? All right, let's look at another example. Okay, so this one, we would attack this one the same way that we attacked the last one. First, we identify that it's an exponential function, or I should say an exponential equation here, because the exponent has a variable in it that we're trying to solve. So we're going to apply the log onto both sides. That allows us to use the property. So this is the exponent, and we have to consider it a group because they're being added together. So we're going to put it in a grouping symbol for now. And so when we put it out front in the grouping symbol, and we now know that this group is being multiplied times log of 6. So we need to undo the multiplication. So now that the group is all alone, we can take the grouping symbol off. And so we will have, let's go ahead and plug this in. Don't forget to put the base in. 0.386, 0.387 if I round that up. Subtract 4 on both sides. So we get 0.387 minus 4, negative 3.613, approximately. I probably wouldn't have rounded it, and I didn't on the calculator. I'm going to go ahead and round my final answer to 3 decimal places. And it's okay for our x value to be negative here. When we add it to 4, we'll get a positive exponent, and 6 to that number should give us 2. Okay, let's take a look at another example. Okay, so when you look at this equation, first thing you should notice is where the exponent is, where the variable is. And so you know you're going to be using logs here. But before we can apply the log to both sides, I want you to notice the difference between these two problems here and this one here. Notice in this problem here, we had a base raised to the variable. Okay? Right here, we had a base raised to the variable plus 4. So both of these problems didn't really have anything else going on except for a base and the exponent. Well, this one has some other things going on. And so we have an add 4 and we have a multiply by 9. So actually, before we can log both sides, I hope you're listening, Nicholas. Before we can log both sides, we're going to go ahead and clean this up. So, solving an equation, we know that we undo adding and subtracting first. Okay, and then we know we undo multiplying and dividing. So we're going to undo this multiplication with division. So we got 3 to the x equals 1. But most of you know what this answer is. Okay. And yeah, you could write down the answer right over here. But let's go ahead and use logarithms to be sure of it. Okay? So we're going to log both sides now that our base is alone with the exponent. So we're logging both sides. And then we use that property to bring that x out front. Okay, then this is multiplying, so we're going to undo the multiplication with division. Okay, and now this answer that our calculator gives us should be the same answer we got down here. The one you already knew, because you know that 3 to some number is going to give us 1. Let's find out what the calculator says and see if you're right. So, we got the log of 1, don't forget the base, divided by the log of 3. Let's see what we get. Is that what you thought the answer was? That's right. 0. 3 to the 0 power is 1. I do want you to always show your work on these problems for me. Okay, so just a few things. Just want to remind you, this was on a previous video note, that exponential functions are inverses of log functions. Log base 3 of x equals y. They're inverses of each other. Inverses of each other. Okay? So don't forget that. Don't forget that the natural log of x is log base e. That these are the same thing. Okay? And don't forget that a logarithm represents an exponent. So, Little question, little bonus. Without using a calculator, what does this log equal? See you guys tomorrow.